Okay, this is quite a top-end question. Find the inverse of this function. Now you should immediately be saying, whoa, whoa, whoa. Is this a one-to-one function? Otherwise, we can't do this question. So let's assume this is a part B where we've established that this is a one-to-one function, or we've restricted the domain to force it to be so. So let's just do the method for finding the inverse of this function. Now, you've got to try and get yourself to the level where you can instantly spot that this is a hidden quadratic. And that is based on 2 to the 2x and 2 to the x. And you will see this all the time. This is just laws of indices. But you can see that this one here, I'll need to deal with -3, but this one here is the square of that one there. So I've got a k squared and a k in here. But that means, of course, I have to deal with this -3. Let's do that. So again, just laws of indices. 2 to the x minus 3 is 2 to the x, and 2 to the 3 divided, and 2 to the x plus 1 is 2 times 2 to the x. I can then tidy that up. And now I'm going to apply that crucial bit of knowledge that 2 to the 2x is the square of 2 to the x. And so when I do that, I write 2 to the x in brackets squared, and I also put the 2 to the x in brackets, really to try and emphasize to myself that these are now the sort of root of this equation. I think it's perhaps a good idea to replace the root of the equation with k, and we can see very clearly this is just a quadratic. So this question said find the inverse of this. So how do you find the inverse of a quadratic? It's one of these things you simply have to know the method, otherwise you are stuffed. Well, first of all, we swap the x's and y's around. So I'm going to find the inverse of this function. So I swap the x's and y's around, and then my task is to make this read y equals. And the trouble is we have y here and here. So unless you know the method, you are stuffed. And the method is complete the square. So to complete the square, we never want to see anything other than a 1 in front of the square. So that's why I've factorized the 2 out, because I want to complete the square on just y squared, and then I can half this number. Now, if I multiplied this bracket out, I would get y squared plus 4y plus 4, but there isn't a plus 4, so I've subtracted it. And then I can multiply that out. And so this is now fully completing the square and tidied up perfectly and relatively easy now to find y. So that's it. But you must remember two things. Obviously, the k, if you remember, was 2 to the x. And this is a method. A lot of students just leave it as y equals. Remember what we did here is we were trying to find the inverse of this function. And this is y. So y is a construction that we've used. There is no y in this question. It's f of x. So we're trying to find the inverse. Remember to give it its correct name. Okay, that's it.